Hello and welcome to Tribe Topper. In this video session, you are going to learn about static charges and charging by induction. First of all, let's understand what is electric charge. See, charge is a property of matter due to which it attracts objects, because you know that if you have seen something is charged, they attract each other or repel each other. And for example, if I say, like how you can induce charge on a body. See, generally an atom or any object in general is neutral because every atom has equal number of electrons and protons. So it has equal number of positive and negative charges. So any object is neutral. But when two substances such as say a glass rod and a silk cloth, they are rubbed against each other, then due to friction, as you know, when you rub your hands against each other, you feel that friction is there and that produces heat energy. You feel the warmth in your hands. So that is why when a glass rod and a silk cloth are rubbed against each other, then due to friction, the heat energy is produced. And this heat energy makes the free electrons to leave one object and transfer to the other. So we suppose that there are some free electrons which are present in a glass rod. But initially, these electrons do not have enough energy to leave it and go anywhere. But when we rub a glass rod with a silk cloth, what happens that due to friction which is produced due to rubbing, a lot of heat energy is produced, and this heat energy is now available with the free electrons, which makes it possible for the free electrons to leave that glass rod and go to the silk cloth. Thus, we would say a charge is induced. Why? Because the glass rod now, which had initially equal number of electrons and protons, it has lost the electrons. And because it has lost electrons, it has more number of protons now, so it acquires a positive charge. On the other hand, the silk cloth, which was initially neutral, now it has it has received those electrons, and so it acquires a negative charge. So your glass rod has acquired a positive charge and the silk cloth has acquired a negative charge because of the transfer of electrons. So charge here has been induced due to the transfer of electrons from one object to the other object, which has been made possible due to the heat energy produced by friction on rubbing. So that's why we also actually give it the name of frictional electricity. And because the charges induced here, they are not going to move. That's just the charges induced on a body, positive on one and negative on another. So these charges are static. So these are static charges, and the study of these static charges is known as electrostatics. That means we are talking of the electric charges at rest. Now, as you know how electric charge is induced, let's understand some of the important properties of electric charge. Number one, probably you already know that there are only two types of charges, positive and negative. This you must be knowing because we haven't heard of any third kind of charge. And how do these charges behave? How do they interact with each other? That's the second property, that like charges repel and unlike or opposite charges attract. That means a positive positive or a negative negative, they will repel each other, while a positive and negative, they will attract each other. And third property, which is very, very important, is that charge is quantized. That means the amount of electric charge on a body is always an integral multiple of the electronic charge E. E is the charge which is present on an electron, and its value is 1.6 times 10 to the power negative 19 coulombs. You must remember this value, though it is given on the data booklet, but it's always preferable to remember this value. So charge induced on a body is always equal to what? Q is equal to NE. Here Q denotes the total charge that is induced on a body due to rubbing or by whatever method. N, because in rubbing, the N is the number of electrons transferred, and this number of electrons transferred is obviously a whole number, because you cannot have half electron transferred or 1.5 electrons transferred. Either you have 1 electron transferred or 2 electrons transferred or 10 or 50 or 100. You don't have 101.3 electrons transferred. Since the number of electrons transferred is a whole number or an integer, that's why the charge induced is an integral multiple of E, because E is the charge on one electron, number of electrons transferred is n, then what is the total charge induced? N times E, and we rather write it as plus minus Ne. Why this plus minus? Because the positive and the negative charge, they both are created, positive and negative charges are created simultaneously. So we have, because one is losing electrons, the other is gaining electrons, so they both the bodies acquire equal amount of charges, just with the opposite signs. So this property, this equation Q is equal to Ne, is very, very important. So let's understand what's the other way of charging here. Instead of rubbing, we have charging by induction. So in charging by induction, what do you see here? This, we have taken a neutral metal sphere. A neutral metal sphere means it has equal number of electrons and protons. But the moment they were all distributed uniformly earlier, but the moment this negatively charged rod, this might be an ebonite rod, so let's say a negatively charged ebonite rod is brought close to this neutral metal sphere, what's going to happen? All the positive charge is going to be attracted to this one side, which is closer to this negative rod, because opposite charges attract. So the moment this negatively charged glass rod is brought closer to this neutral sphere, all the positive charge gathers on this end, which is closer to the ebonite rod, negative rod, and all the negative charge is pushed to the farther end, because this negative rod is going to repel it. So the negative will be pushed to the farther end. Now, it's still not charged. It's just the separation of charges has happened here so far. Just the separation of positive and negative charges has happened. But we do not have the sphere as charged yet. Because if I will remove this rod, all the positive and negative will go back to their positions and the sphere will be neutral again. But our purpose is to charge this sphere. So what should we do the next step? That we connect this sphere to the earth. So by connecting the sphere to the earth means either you can add some wire connected to the earth, or even if you are standing and you touch it, through your body, all the electrons, all the negative charge which is farther, that was free, right? This was free. All these electrons will travel to the earth. Now, when the electrons have traveled to the earth, what will happen? You only have the positive charge left here. But they are still tightly held, right? The positive charge is still tightly held in place due to the negative rod, right? Due to that negative rod, the positive charge cannot leave its place and go anywhere. But the electrons were free, so they just moved to the earth. Now you remove your rod, right? So remove the negative rod and you have all the positive charge, because electrons had already flown to the ground, as we saw in the this picture, that now you have only positive charge left and that will spread around uniformly. So the positive charge spreads uniformly on the sphere. So now the sphere is positively charged, right? So what did you notice? That we, number one, in case of induction, in the process of charging by induction, number one, you will always just keep the rod near the sphere. No contact is developed, right? No contact is developed between the charged and neutral sphere. It was just kept near. The charged body is just held near the neutral sphere. So charged body is just held near the neutral sphere. And the second one is that always an opposite charge is induced on the neutral body. So we had brought a negatively charged rod close to it. The positive charge is induced on this body. If I would have brought a positively charged rod, then this sphere would have acquired a negative charge. So this whole phenomenon is called the charging by induction. So that's all in this video session. In the next video session, you are going to learn about Coulomb's forces, which tells us how the charges interact with each other, or how the forces between two charges appear when the two charges are, whether both are positive or negative accordingly. So that's what you're going to learn in the next session. Thank you.